Number 31 is a sum of two logs. We want to put this together as one single logarithm. Now you notice that you have a sum. You know that comes from a product. But you also have these multipliers out here, and you know those come from the exponents. So the first thing I'm going to do is I'm going to bring the 1/2 up and the 1/3 up as exponents. So I'd write it as the log base 10 of x to the 1/2 plus log base 10 of y to the 1/3. And now I've got an addition, and I know that comes from a multiplication. So I'm going to rewrite this now as the log base 10 of x to the 1/2 y to the 1/3. Now this may be good enough, and I'm thinking it might be good enough because I started out with fractions, and I might just want to end up with fractions. But if you don't, we could take these fractional exponents, convert everything to radicals. So we could write this as, yes, as the log base 10 of what, x, square root of x, and then the cube root of y. Now I'm going to claim that you could go from this very first line directly here. What do you notice? You notice you have an addition, so you know you're going to have a multiplication, right? You know it's going to be that. You know, when you take the log of something, that something is called an argument. So it's just a name for something. So you have the log of x and then the log of the y. Those are arguments. So I know I'm going to have the log of that argument times that argument. So I can go right down here directly and write the log of xy. And then you know you're going to bring these up as exponents. So I think you could go from here to here directly. Let's do this one step by step, and then we'll look at how to start from right the beginning line and just go to the end line in one shot. So first thing to do is, why don't we bring these multipliers up as exponents? So we can write this as log base 2 of x cubed plus log base 2 of y to the 1/2 minus, now no multiplier out here, just log base 2 of z. And now I see I've got this sum of logarithms right here, right? I've got a plus right there. So what I can do is I can write that as the multiplication. So let me get rid of that, and I will rewrite that now as this part right here. I'm writing as the log base 2 of x cubed y to the 1/2, and then I still have that minus log base 2 of z. But now I've got a minus here, and those subtractions come from quotients. The positive is the top, the minus is the bottom, so I'm going to write one log base 2 of, as soon as I see a minus, fraction bar, right? As soon as you see a minus, you know you've got a fraction bar. So what goes on the top? It's the one from the positive log, so that's going to be x cubed y to the 1/2, and on the bottom, it's just going to be that z. Now, do you think you could go from that beginning step, the first line, to the last line in one step? Here's how you do it. You look through here. You got a plus and a minus. Now, as soon as you see a minus, you're going to write a fraction bar. You know what? I'm going to do it down here all over. As soon as I see a minus, I write a fraction bar. And I'm going to write this as one single log base 2. So I see a minus, so I write a fraction bar. If it was all pluses, no fractions. All right? Now, what goes on the top? The positive logs go on the top, and the minus log goes on the bottom. So on the top, what are you going to write? You're going to have an x and a y, but you know those multipliers become exponents. So what are you going to put on the top? Well, you're going to have the x. Well, let's keep it all one color, I guess. You're going to have the x, but that 3 is going to come up as an exponent. And what about the y? That 1/2 is going to come up. And the z, well, that's the negative log, right? That's the negative, so that's the one that appears on the bottom.